this is charges across the capacitor. So capacitance charges you can calculate. So C equal to EA by D, the voltage divided by the distance, this area, and divided by distance, and Q equal to C by VD. The current flow to the capacitor can calculate I equal to D by dt QD. Now, the mass swing capacitor sheet, capacitor double or balance with the plate area sheet, the power sheet, CREA Roma, D net are needed. The mass sheet capacitor check Q or C net BD net not needed. The capacitor CY as the young idea so dQD by dt that needed. This is for the capacitor. So the capacitor currents you can write down the equation. The voltage across the capacitor is 1 by C integration ID dt. So this is for voltage across the capacitor. So this capacitor current here, so the voltage will increase like this. So this ID is equal to 0, equal to less than 0, and between the 0 and the delta t, so C by delta t, and greater than delta t is 0. So this is the current ID the equation for capacitor. And the capacitor sheet. Guess how voltage are like the comma swing, T are from the near swing, current at 0 shit, and T net from the delta t yama swing, C by delta t and G delta t and from Yachete. Yamlo D capacitor machine for RB, 1 by C integration, IDT, so when you imagine a 12 yard. So this is for the inductor current when voltage. When there's a current time here, there's a voltage across inductor here. So the current you can draw like this. So this ID equal to 1 by A integration VD dt plus I0. So this is for inductor current and voltage equation. Now the mass swing for our little piece, close like the comma swing, C what is a C out here, and C that is on to the bonus swell yard. Now the Suzu one just see John Yellow to blue yard, idea is 1 by A integration VD dt plus I0 so that imagine that 12 yard. Now, by the way, in that area, we have what is just a young who are you swear at both pit. So, energy storing in data can be calculated like this equation. So, this is the energy load W is equal to half into Li square. W equal to half Li square. This is the energy stored in data. In that time, my Susi are the things that is swine in Galop. If you half AI square today, imagine that 12 yard. So those are the internet voltage in the current relationship diagram. So in that time, I see the Voane, Tassi Jawa, kilogram is 12 yard. So this is for the element equation for the capacitor in data. For the capacitor, so we can write out the equation ID equal to C dVd by dt, Vd equal to 1 by C integration ID dt. So in data, ID equal to 1 by L Vd dt, Vd equal to I dt di by L di by dt. So this is about in data and capacitor equation. So capacitor so jalo current idea C d by dt Vd net 12 yare, Vd 1 by C integration IDDD look 12 yard. In that dialogue, the current I am 1 by L integration VDD net 12 yard, VDR LDD net 12 yard. That was the capacitor in that time, but the day, imagine the picture. So, this was when we are making the switching, so that way there's a current flow into this capacitor. So, the close pay like the comma swing, the capacitor machine who are the current is see what a bone, the Mapobia Palapete. So, complete response is equal to transient response plus steady response. So, complete response is the nature response plus full response. So, the nature response is the KE power minus I0 minus ID minus I0 divided by 10. So, that's equation. So, this is for the nature response. Now, this must be the complete response and nature response. So, you want response of our swing, you cannot people are not the get up, woman people are I know who bound. Yamu Su Bawa swing that the power of people are you are the yellow people are I respond who bound and အဲ့မှာ nature response ကတော့ဘယ်လိုညီမျှခြင်းနဲ့ဖွင့်လို့ရလဲဆိုရင် ke power ke power minus t minus ta divided by တောင်ဆိုတဲ့ညီမျှခြင်းနဲ့တွက်လို့ရတယ်။ဒါပါလဲဆိုရင်ဒါ nature response တွက်တဲ့ပုံစံဖြစ်တယ်။ So this is a nature response. We can write down. So complete response is a transient response, steady response. Complete response is a nature response plus full response. Nature response is ke power minus t by ta divided by tau. So nature response is ke power minus t by tau equation. So that for the exponential function, in this case vst equal to vg e power minus t by tau, vst equal to v0 cos omega t plus theta for sinusoid. Exponential function ကျတော့ vst က v0 e power minus t by tau နဲ့ပေါ်ပြလို့ရတယ်။ sinusoid ကျတော့ vdr ဆိုရင် v0 cos omega t plus theta ဆိုတဲ့ညီမျှခြင်းနဲ့ပေါ်ပြလို့ရတယ်။ So that in this case are the first order circuit. So take out the circuit when switch on. This is R1, R2, R3. So we can draw the equivalent diagram. In this case, VOC is R3 divided by R2 plus R3 VS. RT is equal to R2, R3 divided by R2 plus R3. ID equal to C dV by D by dt VD. Now, the close will pay like the comma. The machine open circuit for our equipment. R3 divided by R2 plus R3 VS. I imagine R1 ကတော့ R2 R3 divided by R2 plus R3 idea C d by dt VD ဆိုတဲ့ညီမျှခြင်းနဲ့တွက်မှာဖြစ်တယ် So that the first order are when close is on, we can find out the current. So in this case, the VOC can be calculated RT ID plus VT. So RT multiplied by C d by dt VD plus VT. So that d by dt VD plus VT by RTC equal to VOC by RTC. That equation we can write down. အဲ့တော့ဒီမှာဆိုရင်ဒီမှာလက်စီးကြောင်းစီးပွားရဲ့လက်စီးကြောင်းကိုတို့ဘယ်လိုတွက်လို့ရလဲအောက် open circuit ပေါ်လေးက RT ရဲ့ ID ရဲ့ plus VT နှစ်ခုပေါင်းလိုက်ညီတဲ့တော့ RT မှာဒီပိုင်း C d by dt VT plus VT နဲ့ဆိုရင်d by dt VT plus VT by RTC equal to VOC by RTC ဆိုတဲ့ညီမျှခြင်းနဲ့ဖော်ပြလို့ရတယ် So test equations are that this shown circuit when the time is straight close at the t equal to 0. And in this case, we have to find out the this voltage. So 5 minus 10 power 3 multiply I. So 5 minus 10 power 3 multiply I plus V down equal to 0. And then I equal to minus V down by 5 multiply 10 power 3. So 5 minus 10 power 3, we got the current. So the Kirchhoff current law. So we use the current channel, current flowing point, the flow of point. So that this is minus I plus VI plus V down by 10 multiply 10 power 3 minus ID equal to 0. So by combining the these equations, firstly you got the RT V down by ID. So that this equation we got, and our VS is minus 3 by 2. So that then you can calculate for the RT value. Now the mass is the also the imagine mass 5 minus 10 power 3 5 kilo ohm. အဲ့ဒါနဲ့ဒီ I နဲ့နှောက်တဲ့ဟာနဲ့နောက် V တောင်နဲ့နှောက်တာဆိုရင်ဒါ0နဲ့ညီးတယ်အဲ့တော့ဒီ current ကိုတွက်တဲ့အခါမှာ I တောင်ဘိုးက V တောင်ကို5 minus 10 power 3နဲ့စားနဲ့ညီးမယ်အဲ့တော့မှ Kirchhoff current law ကိုသုံးလိုက်တယ်ဒီထိပ်မှာဆို current ကိုသုံးတယ်ဆိုရင် C ဝင်သွားတဲ့ current တွေဆိုရင် minus 5 plus VI plus V တောင် by 10 minus 10 power 3 minus ID က0ဆိုတဲ့ညီမျှခြင်းနဲ့ရေးလို့ရတယ်အဲ့တော့ဒီညီမျှခြင်းကိုပေါင်းလိုက်တဲ့အခါမှာဆိုရင် RT က VT ကိုမှ ID နဲ့စားတာနဲ့ညီးမယ်ပြီးတော့မှ VR minus 3 by 2 by တဲ့နဲတယ်ဆိုရင်အဲ့မှာ RT ရဲ့ညီမျှခြင်းကိုတွက်လို့ရမှာဖြစ်တယ် So those are the unit step response function. So unit step response function is this one. So that this is the unit step response at a 0 and this is t0. So that this is t is less than 0 is 0, t greater than 0 is 1. So this is ut minus t0. This is the unit step response function. ဒါပါဆို unit step response function ဖြစ်တဲ့ဒီမှာဒီ graph ကိုပြကြည့်မယ် t ကတော့ t0 နဲ့ငယ်တယ်ဆိုရင်0ဖြစ်တယ် t0 နဲ့ညီတဲ့အခါမှာ1ရှိတယ်အဲ့တော့ ut minus t0 သည် 0 t is less than 0 t0 and then when the t is greater than t0 this will be the 1. This is the unit step response function. So this case you can write down as a unit cell response function. This unit cell response function will decide this one, and this one also the unit cell response function. Well, this circuit is the one. This is a unit cell response function. And this circuit never the unit cell response function. They do zero yare to the top. We have unit cell response level. The bomb gonna zero yare. The wave is a first order circuit. So this is supply voltage 3050 and 460 microfarads. So we write down the equation V0 equal to A plus B e power minus alpha t equation. Therefore V0 equal to A plus e power minus alpha equal to 0 at the time 0, so A plus B. So V infinity A plus e power minus alpha into infinity, so you got the A. So that this is A plus B. So you find out the A plus B equation. So this A value, B value. So then we got this the voltage we got. But let's say a first order circuit. To a first order circuit, to blow you let's say this circuit will say V0 T A plus B e power minus alpha T. So when you imagine it, you will yard. But let's say to a first order circuit or popular time in Chile. And then T equal to 0 mass V0 tell like this way in a B yalame. Now, V infinity major or data you are something A Yama Pit. And any machine that devoted A plus B as we do two machine the capacitor machine the Boa, the Boa machine for a default our mark, police at the Pyrane, like this way, the machine about 5 and our mark, devoted go, not the 5 own and Yame, you might who bound and salame, salad this way, and Edima, two Boreas, either B at Tambo, A at Tambo Yashima Pit. So natural response. So this is what we write out as a differential equation. This inductor, capacitor, resistor. So this circuit we can write down the equivalent circuits as the differential equation. D2 h by dt square plus 2 alpha dh by dt plus omega square ht equal to fd. This is the differential equation. So D are two inductor body. Resistor by capacitor by so we have differential equation or to the Pongane Popaloya. The Pongano D2h by dt square plus 2 alpha dh by dt plus omega square ht as we FD when you imagine you. That second order differential equation. The low resistor who inductor and capacitor who buy the low second order differential equation. And I am not imagine my satellite with the second order H number video satellite day a Pioma integrate like day. Look at Kama swing that derivative at the Yan Shale, a Shale comma, a D2 V by dt square, Escos are tail 12 a 12 comma swing, Fi Damu 1 by 2 S C Yame, omega square as we 1 by S Yama Pit. So in this case, we write down this equation T2s are Vt by dt square plus 2 alpha d by dt Vt plus omega square, not square Vt equal to 0. Then we have to write down the equation. By integrating, we got this answer, and then taking the derivatives, we got this one, and then dividing the both sides. So this one, we got this one, and in the place d2 v by dt square, we substitute the s. So s square plus 1 by rc s plus 1 by s equal to 0. From here, fi is 1 by 2 rc, omega 0 square equal to 1 by sc. Then finally, you got the s1, s2. We got this equation. This is for the characteristic equation. We get it. So the generalized format of the equation is this equation. A1 e power s1t plus A2 e power s2t. This is the generalized equation. So in this case, s1 is equal to this one, s2 is equal to this one. This is the omega 0 and alpha relationship is at this one. Is V0 and delta D in a generalized equation today. V0 are A1 e power s1t plus A2 e power s2t. S1 and imagine yare, S2 are the yare, omega t ne, omega 0 and fi sesame of the imagine yara. So then, in this case, our natural response equation, so we can see this in this equation and natural response. So the SC is less than the 2RC square, A is less than the 4R square C. and V0 is A1 e power S1t plus A2 e power S2t. S12 is a minus alpha plus or minus square root of alpha square minus omega 0 square. S12 is minus alpha plus or minus J square root of omega 0 square minus alpha square. So J is a minus square root of minus 1. This is the natural response of the undamped full barrier absorption circuit. The popular has a dampened machine for them about it. The appliance that RC circuit. Hello circuit is ACR swing 2RC squared and near AR swing 4R squared C and near V0 A1 equal S1t plus a A2 equal S2t to S12 minus alpha plus or minus square root alpha square minus omega 0 square root omega 0 square alpha square G comma so S12 minus alpha plus or minus J square root of omega square minus alpha 0 square root a nature response, the value of the response, dampen the machine, force broke down the machine, the appliance that are the circuit this way, the imagine the Yala. So therefore in this case you can see that this is alpha is a real component, this is the imaginary component. So that we allocate the alpha and this J value on the plane, this is the complex plane. Now, the S12 is alpha, the real pit, the imaginary pit, J bar, any part of the alpha, the J, the plane bond, Tammy, a plane complex plane will call it. So, this word is how we can write down as a root in the complex plane. The root in the complex plane that gets characteristic equation this one, and root can be calculated.